Hi everyone, today in Integrated Math 2, we're going to go over Chapter 6, Lesson 6. Here are the objectives. Make sure you write them down in your notes. Alright, key concepts. Placing triangles on the coordinate plane. We have 4 steps, and here they are. Step 1, we want to use the origin as a vertex or center of the triangle. This makes it easier for us. That's why we always want to start there if we can. And step 2, we're going to place at least one side of the triangle on an axis. And you're going to see in just a minute how that really does help us. Step 3, we want to keep the triangle within the first quadrant if possible. This is not always possible, but when we can, we definitely want to. And what I mean by the first quadrant, remember this one is our first one, second, third, and fourth. So our goal is to keep it positive in the positive quadrant. The last step is to use the coordinates to make computations as simple as possible. So let's try this example 6. Position and label an equilateral triangle, XYZ, with side lengths of 2A. Well, remember, it does say it's an equilateral triangle, which means equal. So all our lengths are going to be 2A. So we need to keep that in mind. Then, this is to help us guide our pace on how to do this problem. We want to use the origin of one of the 3 vertices of the triangle. The origin is always 0, 0. So our first pair is 0, 0. I'm 1/3 of the way done with this problem. Then, what we want to do, it says, is place one side of the triangle along the positive side of the x-axis. Well, if you don't remember, this is your x, and this is your y-axis. So you want to put another length here, another point here, and the reason why it's on this positive side is because it stays the positive length. It makes it easier for us. So I'm going to choose right here. So the length between here is 2A for our x. And then remember, our y determines if it goes up or down. Well, it doesn't. So it stays at the same spot. Because of that, it's at 0. So we got 2 points of our 3 points for our triangle. Then we need to find our third point. And our third point should be located above the midpoint of the base of the triangle. Well, and the reason why it's the midpoint is because we know this triangle is equilateral. So I know the way I distance it here, 1, 2, 3, 4, 5, 6. So I know 3 is that midpoint. And it doesn't tell us how high this triangle is going to be, so I'm just going to have like a dashed line because I have no idea where it's going to be. It could be a really tall one, don't know. I just know it's equilateral. And our goal is to find our other point for it. So from here, I'm just going to kind of do a sketch of one of the triangles, what it could be. So from here, I know right here is going to be like our more or less our midpoint for this triangle. Well, I know the distance between here and here is 2A. And I know from here to here it's A, and another one from here to here is A. That's how we get our 2A. So what I can say for our ordered pair for this one is that I know my x value is A, but I still don't know my y value. So another thing though that I can see here is when I created like this line here, I now can see that I have a right triangle. We can use our knowledge that we've learned before by using the Pythagorean Theorem. The Pythagorean Theorem we can always use when we have a right triangle. We know this has to be 2A because it's an equilateral triangle just as this one's 2A. So we have most of our points. This is the one we're going to have to find our height, which is exactly what we need for our y. So I'm going to use a squared plus b squared is equal to c squared. So our a is right here. So now I'm going to switch it to a little a squared. And here is, well, we don't know yet, so we're going to keep it as big B squared is equal to c squared. Remember, c squared is always our biggest length, our hypotenuse length. In this case, it's 2a. And don't forget the square. So we have a plus, a squared plus b squared is equal to 4a squared. Well, let's get b by itself because the goal is to find out what b is. Minus a squared minus a squared. B squared is equal to 3a squared. And then to get rid of this, because we only want to find one b, we're going to square root it. Then I find out that b is equal to, the a comes out, and we have the square root of 3. So we can say that this last piece is a times the square root of 3. And there we go.